Hello there, welcome to today's class. We shall be continuing from where we stopped in our previous class on chemical equations. In chemical equation, we said a chemical equation is a simple representation of a chemical reaction or a chemical change involving symbols and formula. It can be written in paper form to represent a chemical reaction. So, in today's class, we are going to concentrate on how to balance simple chemical equations, and maybe if there is time, we may also go further on how to solve some simple calculations involving chemical equations. Now, let's take a look at some of the steps on balancing chemical equation. And before we go into that, how do you balance a chemical equation? Or why is balancing of chemical equation very important in chemistry? Now, according to the law of conservation of matter, which states that all matter can neither be created nor destroyed. So, based on that concept, all chemical equations must be balanced in order to comply with the law of conservation of matter. A balanced chemical equation contains or obeys the law of conservation of matter, where number of atoms of the reactants is equal to number of atoms of the product, and also number of moles of the reactant is also equal to the number of moles of the products. So let's take a look at some of the steps involved in balancing simple chemical equations. Now, steps involved in balancing simple chemical equations. Now, the first step we have here is, it says, write the correct chemical symbols and formula of the reactants and product. It is very important. If you want to balance a chemical equation, the first thing you do is to identify the chemical symbol, or to write the correct chemical symbol of the reactants and the product, and also the correct chemical formula of the reactants and products, before you can now go further on balancing the equation. Number 2 is, for reactions involving diatomic gases or molecules like oxygen, hydrogen, nitrogen, and chlorine, it is very important that we indicate the number of atoms as O2, H2, N2, and Cl2. Of course, these are called diatomic gases. So if they exist alone in an equation, or if they exist, or if they are written freely without combining with other atoms, they must be indicated with the number of atoms as to show that they are diatomic gases while writing a chemical equation. Okay, now the number 3 there as the step is, if there are free elements in the equation, balance them first before the other substances. Of course, in some cases we have free elements or free atoms in the equation, so those free atoms must be balanced first before we go into other atoms. Let's take a look at a common example of an equation like magnesium reacting with hydrochloric acid to give us magnesium chloride and hydrogen gas. Of course, this is not a balanced equation, but it's just to show you how a free element can exist in a chemical equation. So in such case now, we try to balance the free element. A free element here is magnesium. So we try as much as we can to balance the free element before we take a look at the other atoms or the other substances in the equation. Okay, so now the next step we have here is, it is important that we state the physical states of the substances as subscripts in the form S for solid, L for liquid, G for gas, and in some cases AQ for aqueous solutions. That is, solutions involving water as solvent. They are called aqueous solutions. Now, these are always written as subscript in front of the symbols or in front of the formula of the compound. It is very important. For example, now, water can exist as both solid, liquid, and gas. So in a particular reaction, water can be, the physical state of water in that reaction may be indicated as liquid, and in another reaction it may be indicated as gaseous. So you should not be surprised when you see water being indicated as gas, and in another equation it may be indicated as liquid. that shows the physical state of that substance in the equation or in that particular reaction. So it is very important that in all cases or in all chemical equations, we must make sure we indicate the physical state of the reactant and the product. Okay, now going to our next step, we have said balance the number of atoms and moles of both the reactants and product. Yes, after you've indicated all this, the last step you do is to balance the number of reactants and product, the number of moles and number of atoms. Of course, in trying to balance chemical equation, number of atoms is also equal to number of moles, and number of moles is also equal to number of atoms. So if I have 2 atoms of hydrogen at my left hand side, at my right hand side I can have 2 moles of hydrogen. Okay, if I have 2 atoms of sodium at my left hand side, on my right hand side I can have it as 2 moles of sodium. It is the same thing. So in trying to balance chemical equation, we can sometimes change number of atoms to number of moles. These are the few steps that can be used to write a balanced chemical equation. So I believe with these few steps, it will be a very simple task for us to balance chemical equation anywhere, anytime, and in any exam condition or anywhere we come across a chemical equation, we will be able to balance them using these few steps that we have highlighted here. So with this, I think we've come to the end of today's class. I hope to see you in our next class, where we'll be looking at some examples of balanced chemical equations. I don't think you like to miss that kind of class, because all we have done today will be looked into in details in that class. So hope to see you in that class. Bye for now.